This is the Lines Through the Coordinate Plane tutorial. When dealing with lines in the coordinate plane, we can describe those lines in a couple of different ways. You could describe them as saying the line is running to the left, to the right, it has a rising slope or a falling slope, or you could describe them in a mathematical way. There are a couple different equations that we use to describe lines mathematically. The first is in slope-intercept form, and the second is in the point-slope form. Now, in dealing with the slope-intercept form, we have the equation y is equal to mx plus b, where m is referring to the slope of the line that we're describing, and b is referring to the y-intercept of the line that we're describing. Now, the y-intercept of a line is the point where the line crosses the y-axis. We also have x and y in the slope-intercept form, and x and y are any x-coordinate and y-coordinate from any point in the line. So you could pick any point along that line and use the x-coordinate and y-coordinate of that point inside of this formula, the slope-intercept form. And we'll use some examples of this in a moment. The second form is point-slope form, and its equation is y minus y1 is equal to m times x minus x1. Now, when we write equations of lines using the point-slope form, we use m for the slope again, and the y1 and x1 are just the x and y coordinates of any point along that line. The x and y by themselves, we just leave alone in point-slope form, and I'll show you some examples right now. Let's first go back to slope-intercept form and we'll take a look at the examples. In this first example, right here, we have the equation of a line written as y is equal to 3 times x plus 6. Now, based on what you know of the formula for slope-intercept, which is y is equal to mx plus b, you can tell that the 3 here is taking the place of the m, which means that the slope of this line is going to be 3. And the 6 is taking the place of the b, which means that the y-intercept of this line is 6. And in a moment, we'll plot some lines on a coordinate plane so that you can see what this actually looks like. Now take a look at the next equation. 2y is equal to 4x minus 10. Now in this case, they haven't actually given you the problem in slope-intercept form yet. They've given us a problem that resembles putting a line in slope-intercept form. You know that to be in slope-intercept form, we have to be in the generic equation y is equal to mx plus b, meaning y is alone. And in this green case, we have 2y. So in order to put this line in the slope-intercept form, we'd want to get rid of that 2. And to do so, we'd divide both sides of the equation by 2. And we'd get a line that's just y on the left now because the 2's have canceled each other out, is equal to 4x over 2, which is 2x, minus 10 over 2, which is 5. So really, that equation above, written in slope-intercept form, is actually y is equal to 2x minus 5, where the 2 is the slope of this line, and the negative 5 is the y-intercept. And we'll show you what you can do with that later. Lastly, this problem down here is written as 0.25y is equal to 3.4x minus 0.5. Now again, we want y alone. We don't want just 0.25y. So, since the 0.25 is being multiplied by y, I'm going to divide by 0.25 on both sides of the equation. The 0.25 over 0.25 is going to cancel on the left-hand side, and we'll have y by itself. Now, whenever you divide something by 0.25, you're dividing it by 1/4, and that's the same as multiplying by 4. When you divide something by 1/4, it's the same as multiplying by 4. So, let's go ahead and multiply 3.4x by 4, which would be 13.6x, and a negative 0.5 by 4 would be a negative 2. So, if you were to rewrite that equation in slope-intercept form, it would be y is equal to 13.6x minus 2. Now let's work with point-slope form, and we're going to pull out the important pieces of information, and we're going to rewrite the equations in point-slope form that are not in point-slope form, if any. We'll begin with the top equation here. Y minus 6 is equal to x minus 4. In this case, you know that positive 6 must be your y1, because normally the equation in point-slope form is written as y minus y1. So y minus 6 in this case. So y1 must equal 6. If y1 were negative 6, it would have been y plus 6, because a minus and negative is a plus. And you don't see any sort of an m written down in front here. There's no number here. When there's no number written in front of a set of parentheses, then the number must be 1, and we don't have to write a 1 in front of everything. So in this case, the slope of this line must be 1. And the x-intercept, or excuse me, the x point from this line, x1, is going to be positive 4. Even though there's a negative here, that negative is supposed to be here because it's x minus x1. So in this case, x minus 4. 4 must be x1. So those are the important parts of the information from point-slope, and it's already written in point-slope form. There's no changes necessary. Now take a look at the second equation down below that. Y plus 3 is equal to 4 times x minus 2. So in looking at this equation, could you tell me what the x1, y1, and slope of that line must be? Well, let's go over it. The x1, y1, and slope of this line. Well, the slope comes before the parentheses on the right, so in this case, the slope must be 4. The x1 must be a positive 2, because it's x minus x1, so x minus 2 in this case. And the y1 coordinate must be a negative 3, because it's the opposite of what is here. If it's a negative or a positive 3 here, then our y1 is a negative 3. And if it were a negative 3 here, then our y1 coordinate would be a positive 3. Alright, let's take a look at the last equation. Y minus 2 is equal to 5 times x plus 1. Again, go ahead and try to tell me what the x1, y1, and slope are for this line. The x1 must be a negative 1, because it's the opposite of whatever this value is. And the y1 must be a positive 2. Because it's the opposite of that value. The slope, again, is the number that comes before the parentheses. So in this case, it's a 5. Now that you know about these two equations, and trying to get those things, these equations, into a standard form, the standard slope-intercept form or the point-slope form, we're going to look at some actual problems, and you can see how being able to manipulate these to get them into the right form is going to be beneficial to you. Now for our first practice problem, I'd like you to write the equation of a line in slope-intercept form. And remember that slope-intercept form is y is equal to mx plus b. So we'll take a look at a couple things here. First, we want to know the slope of this line. And if you recall, all we need to calculate the slope of a line are the x and y coordinates of two different points. So I'll label this point 1 and this point 2. So m is equal to the y of coordinate point 2, which is 5, minus the y of point 1, which is 7, over the x of point 2, which is 6, minus the x of point 1, which is 4. I'll simplify that down below. 5 minus 7 is a negative 2, and 6 minus 4 is a positive 2. So that fraction simplified is negative 1. So the slope of this line, I can already tell you, is negative 1. That would go right here in m. And we can solve for the y-intercept. We can solve for the y-intercept by taking either one of these points and plugging the x and y coordinate into the x and y of our slope-intercept form. So, the x and y coordinate of point 1 I'll use. So y, I'm going to rewrite this equation down below. Y, which is the y coordinate here of point 1, is 7, is equal to our slope, which we know is negative 1, times the x coordinate of this point, which is 4, plus b. And we're going to solve for b, the y-intercept, because we don't know what it is. So 7 is equal to negative 1 times 4, which is negative 4, plus b. We want to solve for b alone, so I'm going to add 4 to both sides of the equation. 7 plus 4 is 11. The negative 4 and positive 4 on the right-hand side of the equation cancel out, and we're left with b. So in this line, our y-intercept is going to be 11. So we can rewrite the equation of this line in slope-intercept form as y is equal to our slope, negative 1, times x plus our y-intercept, which is 11. Now the reason we leave the y and x as variables in this equation is because they're referring to the y and x coordinate of any point of this line. The slope of a line is never going to change without modifying the equation of the line. And the y-intercept, the place where that line crosses the y-axis, is also never going to change. They're constants, which is why they're actually written in the equation. The x and y, like I said, are any points you want to plug in along that line, and you know that a line has an infinite number of points. So this equation will always work for any of the points on that line. Alright, so that's how we write a line in its equation in slope-intercept form, given just 2 points. Let's take a look at another practice problem. In this problem, they'd like us to write the equation of the following line in point-slope form. And they've given us some information about this line. They've told us that the x-intercept is equal to 4, and the slope of the line is equal to 2/3. Now, if you recall from earlier in the tutorial, point-slope form is written as y minus y1 is equal to m times x minus x1. So we're going to need a point somewhere along this line, but it doesn't look like they've given us one. They've given us the x-intercept and the slope. However, recall that the x-intercept is just the value of x when y is equal to 0. So that really is a point. The value of x, which is 4 at the x-intercept, when y is equal to 0. So the point of the slope, or the x-intercept, is 4, 0. So we can use the x-coordinate and the y-coordinate of this point and plug those into x1 and y1 in our equation. And our slope, 2/3, we can plug into m. So if we did that, our equation would be written as y minus y1, which is 0, is equal to m, which is 2/3 as provided in the problem, times x minus x1, which is 4. It's the x from our x-coordinate. So this is actually the equation of that line written in point-slope form. You'll see some more practice with these formulas, the point-slope form and the slope-intercept form, in the practice problems that follow in this section. Lastly, I want to leave you with just a couple interesting things about lines through the coordinate plane. The first is this. Whenever you're dealing with parallel lines, they always have the same slope and different y-intercepts. So keep that in mind. Parallel lines have the same slope, but different y-intercepts. Any two lines in the coordinate plane that intersect are two lines with different slopes. They may have the same y-intercept, but they have different slopes, so they're going to intersect at some point in the coordinate plane. And lastly, any two lines that coincide, meaning that lay right on top of each other so that you couldn't distinguish that there's more than one line there, they have the same slope and the same y-intercept.